Hello everyone, I am teacher Wang Xing. Today, let's continue to learn about air pollution control technology. Chapter 9, Section 3, Condensation Method for Controlling VOx Pollution. Let's learn the condensation method together in this class. This volatile organic compound treatment process. Firstly, the condensation method is used to control VOx pollution. It is the use of substances at different temperatures. The property of having different saturated vapor pressures, reduce temperature to increase system pressure, or a method of reducing temperature while increasing pressure, condensing pollutants in a vapor state such as VOx, and separate it from the exhaust gas. This law is particularly applicable to the treatment of waste gas. Volume fraction at 10. Organic hydrogen gas above the negative quadratic power of condensation method. In theory, a high degree of purification can be achieved, but when the volume fraction is below the 6th power of 10, further freezing measures need to be taken, greatly increase operating costs. Therefore, condensation method is not suitable for treating low concentration organic gases and often used as other methods. Pre-treatment for purifying high concentration waste gas to reduce organic emissions. Composite recovery of organic matter. Recycling asphalt smoke using condensation method in coking plants. To eliminate pollution, tail gas of oxidized asphalt from refineries and felt factories. Also use condensation method to recover oil first, then it will be sent for combustion purification. In addition, high humidity exhaust gas. The condensation method can also be used to condense water vapor to reduce gas volume. Below, let's learn the principle and process of condensation together. Firstly, the principle. Substances at different temperatures and pressures, having different saturated vapor pressures corresponding to harmful substances in exhaust gas. Temperature at saturated vapor pressure. It is called the dew point temperature of the mixed gas. That is to say, under certain pressure, its gaseous substances begin to condense. The temperature at which the first droplet appears is the dew point temperature, abbreviated as dew point. Therefore, the harmful substances in the mixed gas. The temperature must be below the dew point in order to condense. Heating liquid at constant pressure. The temperature at which the first bubble of liquid begins to appear, abbreviated as bubble point. The condensation temperature is generally between the dew point and the bubble point. The closer the cooling temperature is to the bubble point, the higher the degree of purification. Usually, compression method can also be used, causing gaseous harmful substances becoming liquid at critical temperature and pressure in order to remove or recover harmful substances, but due to the high cost, currently used less. Let's learn about condensation calculation together. 1. Calculation of phase equilibrium constant. Phase equilibrium constant. It refers to under a certain temperature and pressure. When the gas-liquid two phases reach equilibrium, the molecular fraction Y of any major component, I in the gas phase, ratio to molecular fraction 11 in the liquid phase. When gas-liquid equilibrium occurs, calculate as follows. Under atmospheric pressure, if there are significant differences in the molecular structure of components in the material system, like water and alkane alcohols, aldehydes, ketones, etc., all form a series of compounds. At this point, the gas phase can be regarded as an ideal gas mixture. Under medium pressure, the gas phase is a real gas. When the molecular structure of the material system is similar, the liquid phase can be regarded as an ideal solution. The gas phase can be seen as the dew of a real gas. Calculation of point and bubble point temperatures. Now let's learn together. Calculation of dew point and bubble point temperature. Firstly, the calculation of dew point temperature. Assuming that a gas mixture contains multiple components, its composition is Y1, Y2, Y, all the way to N. Then the sum of Y divided by me is 1. The temperature at the waypoint when the system pressure is P is F. By looking up the table, the equilibrium constants K1 and K2 of each component can be obtained. Key until not. Liquid droplet Xi in equilibrium with this gas mixture. Calculate as follows, and the sum of each component in the droplet should be equal to 1. If not equal to 1, then reassume the dew point temperature and perform calculations. To equal 1, the corresponding temperature at this point is the dew point. The second is the calculation of bubble point temperature. Assuming the bubble point temperature at system pressure P is T, check the table to obtain the equilibrium constants K1 and K2 of each component. Key to note: the gas phase composition in equilibrium with this liquid mixture becomes Y. The calculation process is the same as the dew point temperature. Is the sum of Y equal to 1? To determine if the assumed temperature is correct. 3. Let's learn about the condensation and liquefaction rate of VOX together. F refers to the amount of condensate after condensation. Molar fraction of feed VOX, represented as follows. The material balance equation in the condenser is as follows. According to the gas-liquid equilibrium relationship, heat transferred during condensation QC can be calculated from heat balance. With QC, we can use the heat exchange equation. Calculate the heat exchange area of the condenser. Using the heat balance equation, obtain the required cooling or freezing medium flow rate. Last, let's learn about the types and equipment of condensation together. Firstly, contact condensation. It refers to the contact with the condenser, condensate gas and cooling medium, usually in direct contact with cold water, and make the VOX components in the gas condense. The condensate and cooling medium are discharged in the form of waste liquid. Cooler. Contact with the condenser is beneficial for enhancing heat generation, and the condensate needs further treatment. Commonly used contact condensation equipment includes injectors, spray tower, packing tower, and sieve tray tower. Secondary surface condensation, also known as indirect cooling. The cooling wall separates the cooler from the coolant. Therefore, the coolant component is relatively single, can be directly recycled and reused. The commonly used indirect condensation equipment is a tube condenser, fin tube air-cooled condenser, spray-type condenser, and spiral plate condenser, etc. 3. The design calculation of the condensation system starts with condensation system design variables. Given the removal efficiency and outlet concentration, key design variables required in condensation system design. It's the condensation temperature, removal efficiency of condenser, dependent on the properties and concentrations of each component in the emission stream. For example, high boiling point and low volatility VOX, easier to condense than low boiling point VOX. Achieving the given removal efficiency or outlet concentration, required temperature, depends on the vapor pressure of VOX under gas-liquid equilibrium conditions. For a given VOX, as long as the given removal efficiency, temperature required for condensation, it can be determined based on its vapor pressure and temperature. Coolant, you can choose according to the required cooling temperature. 2. Determination of design variables for condensing systems. Firstly, condensation, temperature calculation. For a given removal efficiency, partial pressure of outlet VOX, it can be calculated by the following equation. Under gas-liquid equilibrium conditions, partial pressure of VOX equal to its vapor pressure at equilibrium temperature. Therefore, by determining the temperature at which gas-liquid phase equilibrium is reached, then the condensation temperature can be obtained. According to the required condensation temperature, the type of condensing agent can be selected. 2. Thermal recombination of condensers to achieve a certain level of removal, and the heat that must be extracted from VOX gas. By the condensation heat of VOX, calculate the sensible heat change of the gas. The thermal load of the condenser is shown in the following equation. Determine the evaporation heat of VOX. Under typical circumstances, the evaporation rate varies with temperature. Using the vapor pressure shown in the Cox pressure map, temperature data, regression can be used to determine the vapor pressure and temperature. Data. Calculate the enthalpy change of condensed VOX based on 1 minute, as follows. Calculate the enthalpy change of uncondensed VOX, also based on 1 minute, as shown in the following equation. Calculate non-condensing steam, or the change in enthalpy of air, based on 1 minute, as shown in the following equation. The heat load calculation of the condenser is as follows. Typical size of condenser, based on the total thermal load of the condenser system, and total heat transfer coefficient, to estimate its size, and the total heat transfer coefficient. It is based on the gas flow, estimated based on the respective heat transfer coefficients of the coolant. For gas flow, the coolant and the specific shell and tube system you are using, based on their respective physical and chemical properties, accurately estimate its various coefficients. Because it is impossible to provide such a detailed introduction here, therefore, the values used for estimating the total heat transfer coefficient are based on a conservative estimate. The following equation can be used, estimating the required heat transfer area for the condenser. Flow calculation of condensing agent. The heat extracted from the gas is transferred to the condensing agent, according to the principle of energy balance. Calculate the flow rate of the condensate. Classmates, through the learning of this lesson, basic understanding, the principle of using condensation method to treat FOX pollution, and its process flow. That's all for today's class. Thank you all.